The height in meters of a projectile shot vertically upward from a point 2 meters above the ground level with an initial velocity of 24.5 meters per second is given by this equation. So that's the height. And so height is in meters and time is in seconds. Find the velocity after 2 seconds. So we know v of t is the derivative of the height function, and we're going to get, so 2 goes to 0, 24.5t just goes to 24.5 when we differentiate, and then the power rule, when we bring down the 2 with a negative 4.9, that's negative 9.8t. So we have our velocity function, and we just have to find it at 2 seconds later and 4 seconds later, so we just plug those in. So 2 seconds later, the velocity is 4.9 meters per second, so it's gaining 4.9 meters every second. And 4 seconds later, I guess it's on its way down with negative 14.7 meters per second. Part B says, when does the projectile reach its maximum height? So let's go quickly look at the graph of this function. We know it's a downwards opening parabola, so it goes, the object goes up and comes back down. And we know at the very top, when it reaches its maximum, it instantly stops and then comes on its way down. So velocity would have to be 0 there. So maximum height for something that looks like that, it goes on its way up. So as we can see, 2 seconds later, the tangent line was positive, and then 4 seconds later, it's negative. Maybe somewhere in between there, it reaches its maximum height. So if we think of it algebraically, it's just a parabola, and we can find the vertex and see what the vertex is, or we can go look at the graph on our TI. So if I'm doing it algebraically, it's just going to be the vertex formula. The t coordinate will give me the time, so negative b over 2a. In this case, b is 24.5, so negative 24.5 over 2a is negative 4.9. And if we do that, we get 2.5 seconds. So without any calculus, we can see that the vertex occurs 2.5 seconds later, and that'll be our maximum height. Also, we can look at it graphically. So I've put the position or the height function into the TI, and my window is, let's see if that works for us, x min and x max are there. So between 0 and 6 for the x's and negative 20 to 35 for the y's. I'm going to graph it, and it looks like we have the parabola shot up from 2 meters up above, and then it goes all the way up and comes back down. So I guess we don't need this part either, but it's okay. So somewhere there is the maximum height. Let's go use the feature of the TI, second trace, and then I go to maximum. So I go down and select maximum number 4. I go to the left of the bump and I push 1 enter. Then it says go to the right side of that. So I'm going to go to the right side of the little bump and I'm going to push enter. Now it says, should I guess? I'm going to push enter again, and it guesses for me. And notice it's happening at 2.5 seconds later, just like I found it with my algebraic method. And notice it's also giving me the y value, which is already the height of 32.625. So let's make a note of that also. So with my calculator again, I used the maximum feature and I got the x or the t to be 2.5 seconds and the y or the height to be 32.65 meters. And I could have gotten that by just plugging the 2.5 into my original height function over here as well. Now, the other idea we talked about is that, so we actually found c also, because C was asking for what is the maximum height. We already found the y or the h value. When does the projectile reach its maximum height? So without algebra we did it. Now let's quickly do it with this idea of v of t has to be 0. V of t we know is this function right here. So when that equals 0, that's going to give me the time that it reaches its maximum height. And notice I'm getting the same thing I will get when I did the vertex formula. So that's going to give me 9.8 t equals 24.5. And when I divide that by 9.8, I'm going to get that same value of 2.5 seconds later, it's reaching its maximum height. So one way to get the maximum height in this case is to actually just use the vertex formula, plug it in, and get the height and the y value. Or if all you're looking for is when, which is the time, you can also just take v of t and set it equal to 0, because at that time, instantly at the highest point, it stops for a fraction of a second and then it's on its way down. Part D says, when does it hit the ground? So our picture is looking something like this. So it goes up, it's the very, it reaches the highest point, and then it keeps coming to the right. And when does it hit the ground? Well, basically it hits the ground when I go all the way down here to the x-axis. So if I'm looking at a quick little picture here, it goes and it comes. When does it hit the ground? Right there, it hits the ground, which means all I'm looking at is an t-intercept. When it hits the t-axis, that's when it hits the ground. And notice when it hits the ground, the height is 0. So I take my original height function and I just set it equal to 0 to figure out when it hits the ground. And that was 2 plus 24.5 t. So when it hits the ground, the height is just going to be 0. And I can solve this by using the quadratic formula if I want to do it algebraically. Or I can just go ahead and look at my TI and figure out when it hits the ground by using the features of the TI. So again, you could do it algebraically by just solving this quadratic equation using the quadratic formula. Let's go to our TI and try to find it with our TI. So I'm going to do second trace, and now I'm going to go to number 2. So the second on right after value is number 2, because I think the screen gets cut off here a little bit. There you can see it better. So a 0 means the same thing as an x-intercept. A 0 and x-intercept is the same thing. So push enter, and it's saying left bound. So I'm going to go somewhere to the left of the x-intercept, or the t-intercept in this case. So I'm going to go somewhere to the left of my focal point, right about there, which is near where it hits the t-axis. I push enter. Then it says right bound. So just like I did for the bump of the maximum, I go to the right of that x or t-intercept. I push enter. And then my third enter will guess the value for me. So 5.08 approximately is the time, notice, when the height or the y is 0, and that's when it hits the ground. So it goes and travels around 2 seconds. We know it was on its way up. Around 4 seconds, we knew it was on its way down. And at 5.08 seconds, it hits the ground. So 5.08 seconds later, it hits the ground. And last thing we have to answer is, with what velocity does it hit the ground? So when it comes like this and it hits the ground, what is the velocity at that time? Well, we have the velocity function, and that's just v of t equals 24.5 minus 9.8 t, and we know it hits the ground at this point. So it hits the ground at 5.08 seconds later. So if we want to know the velocity at that time, all we have to do is just plug in the velocity of when it hits the ground, and we should be able to get the velocity. So it looks like we're going to get about 25 or negative 25.3 meters per second is the velocity that it hits the ground with. And that makes sense because it's coming down and it's got a negative tangent slope when it hits the ground.